Okay, hello everyone. So, welcome back to class after our nice weekend. And we have our quiz here. So, again, this is the quiz that we took on Friday. And it's 6 questions long, most of them being definitions. And then I think it was just 2 calculation answers. So, let's go ahead and go over this quiz. So number 1 says the height of all NBA players is an example of what? A population or a sample? Okay, well, if it's all NBA players, then that would be a population. Keyword there being all NBA players. If it was just a selection of NBA players, then that would be a sample. Number 2, true or false, the treatment group is exposed to changes in the experiment. That would be true. So, a treatment group is the one that we actually give the quote-unquote treatment to. Whatever changes we're making in the experiment, the treatment group is going to get those changes. It's the control group that doesn't get any of those changes. Number 3, an extra variable not accounted for that can suggest an incorrect correlation is an example of what kind of variable? So, again, this is one of those things that seems like it fits into our phenomena, but it doesn't actually. This is a confounding variable. Something like the ice cream causing murders or firemen making horrible destruction at the fire. Yeah, it's a confounding variable. So, C. Okay. Then we have this table here. This is pulled from Hawks. So I've got 2 questions on this table. 1, what are the characteristics of the data from this table? Well, first of all, is it nominal or ordinal? Well, there's no order to these things. A dishwasher isn't higher up on a ladder than a dryer. They're both just appliances. So this is nominal because there's no order. Then is it quantitative or qualitative? Well, I don't see quantity in these datas. What I do see is a quality of the data. So being a washing machine is a quality of an appliance. So we go with B, nominal, qualitative. Okay, then we had to create a frequency distribution. So first off, fill in all the scores. So all of the different types of appliances go into these scores. Then the frequency is how many times each of those things happened. So like for dishwasher, we have 7 of them. I believe washing machine has 4, and then refrigerators 3, and so on and so forth, until we get all of our frequencies, which add up to 25. Now, again, it's always a good idea to make sure that the sum of all your frequencies is the same as the number of data points you have. You want to make sure that you actually hit all of these when you're doing your frequencies. If this is above or below, you need to go back and recount your frequencies. Okay, once we have our frequencies, though, we can get our relative frequencies. So we get that by taking each of these frequencies and dividing them by the total. So, for instance, dishwasher, that's a frequency of 7. We divide that by 25, and we get 0.28. Do that for all of these, and we get our relative frequencies, which should add up to 1. Again, if it doesn't add up to 1, it can be close to 1. That's okay. That might just be a little bit of rounding error. But as long as it adds up to something close to 1, we should be fine. If it's too much farther away from 1 than maybe a point or 2, then we need to go back and see what went wrong. Percents, to get those, we just take the decimal on our relative frequency and move it twice to the right, and it gives us our percent. And they should all add up to 100. Okay, number 6. We have our list of data here. The first thing we should do if we're going to get mean, median, mode, and range is order it. So I've gone ahead and put the data in order on this side. So mean, we add all these up and then divide by the number of data points we have. So if we add all these up, we get 31. And divide by 7, we get 4.428. But we want to round it to 2 decimal points, so we round that 2 up to a 3 since the next one was an 8. Median is the middle number of your ordered data. So our middle number is number 5 here. I did have a few people give me 6, but that's because they did not order their data when they went for their median. Remember, you need to order your data. Mode is the number that occurs the most. So, right there. And range. You take the smallest number and subtract it from the highest number, and we get a range of 7. And then the bonus question. Basically, if you gave me a bonus question that made sense, or you gave me an answer for your bonus question that made sense, I gave you the 5 points. I don't think there was anybody who gave me an answer that didn't make sense, though. So if you answered it, basically, you got the 5 points. Okay, but that is our quiz. So a lot of this has to do with our frequencies and our frequency distribution, because what we were talking about was organizing our data. So now let's go take a little bit closer look at organizing data. So I'm over on Hawks now, and I've got an example here. It says the following bar graph represents the number of dogs and cats treated by a local vet during 1 week. Okay, so I'm guessing most people are familiar with a bar graph and what it represents. However, I want to get into some particulars here. So, again, with a frequency distribution, that's kind of like the most basic way for us to start organizing our data. Now, these graphs are also very important, and the reason why is because we as human beings, we don't look at numbers as well as we do just looking at shapes and sizes. We're very visual creatures. So, we can look at numbers all day, and with practice, yeah, we can understand what those numbers are doing, but a graph is a much simpler way of observing all of the data in relation to each other. So again, like for instance this one, we have animals treated by a vet over a week. So there's certain parts of this that I want to make sure we understand. First of all, a graph should always represent your data entirely and accurately. So the graph needs to be able to explain what this data is and show it accurately. Okay? So first things first, we have a title here. So this is animals treated by vet. I actually don't like this title for this graph, believe it or not. A title for a graph should tell us everything that we can expect to see in the graph. So it should tell us what we are measuring with this graph, it should tell us how we're measuring it, and it should tell us where it came from. So if I were to retitle this, I'd say animals, or really dogs and cats, treated by the name of the vet over a week period. Okay? Then the next part we have is the labels of our axes. So this is the number. Again, I don't really like this label. It should explain more. It should be like number of patients, number of animals. And then this is the day. That's probably okay. It's got the days of the week listed here. Okay. And then the next part of this graph is the bars of the bar graph. So the bars show us basically the frequency of each of these animals. So we have frequency for dogs and frequency for cats. So this right here is all of the dogs, and then on top of it is all the cats. Again, all of the dogs, then on top of it is all the cats. I don't actually really like this layout for this graph. I prefer a side-by-side bar graph if I'm going to do something like this. So again, here's all the dogs and then all the cats. So we can see there's 5 dogs and 1 cat. We can see that here as well. 5 dogs, 1 cat. Now, what this one is useful for is knowing the total amount of dogs and cats throughout an entire day. because this is going to tell you, okay, we had 6 total. Here we had 11 total. Here we have 8 total. But it can get a little bit more confusing as to, okay, if I want to break out cats and dogs, which one is which? Because a lot of people will look at this and say, okay, we had 5 dogs and 6 cats. No, we had 1 cat. It's just that the cat is sitting on top of the dog bar. Okay? So, this is a graph I don't really like. I'll show you one that I do. So, here is the per capita income for several states. And I like this title a lot better. This says per capita personal income by state for 2003. So first of all, it tells us what we're measuring. Personal per capita income. Then it tells us how we're measuring it. We're measuring it by state. Then it says where this came from for 2003. Okay, so there's a lot of information here. And in fact, this is all the information we need to expect from the graph below. And it tells us a lot about the graph just here in the title. Down here, on our axes, we have income in dollars. That's great. It's telling us that this is the income that we're looking at, and it tells us how it's measured. So in dollars, so this is $10,000, $20,000. Down here is the state, which it's labeled correctly. That's great. This is a much better graph, I think. Okay. Now, some things about these graphs, bar graphs in particular. They are really good at showing frequencies. Okay? They're also really good at showing quantitative data. So, this is quantitative here. How much is this one making in Nevada? How much is the average person making in Nevada? You know, that's quantitative data. It's very good at showing that. It can show qualitative as well, but as frequencies. Okay. Now, the next type of graph is way down here. That's the circle graph, or a pie chart. So, this one, if we look at the description, the Pizza Pie and Go sells about 1,400 one-topping pizzas each month. The circle graph displays the most requested one-topping pizzas by percentage for 1 month. So, circle graphs are very good at showing percentages because bar graphs, it helps us understand, you know, amount. So compare this amount to this amount. How big is this compared to this? Circle graphs are great at showing percentages because the way that we understand percentages in our heads is as pieces of things. We can understand if you break something in half, that's a half. If you then break that half again, that's a fourth. Okay, and those percentages line up with those pieces. So, for instance, mushroom right here, this part of the circle graph. 45% is almost a half. It's almost 50%, and yes, indeed, this is almost half of this pie taken up. Then we have the others that make up the rest of this. So, 25% would be a quarter. 17's pretty close to 20, so it's a little bit off of a quarter. The quarter would be about right here. But we can understand, yeah, okay, I know what these pieces look like. I can understand what they look like in relationship to each other. And I know that, okay, if I add all these together, I get one whole pie, one whole circle. And so that is the benefit of these circle graphs, is they're very good at showing percentages. Okay. So one thing I do want to make sure that I go over real quick, though, is that if we have the number of things represented by this data, so again, this is 1,400 pieces of data here. If we know the total amount of data, we can actually work backward and get from our percentage to our frequency. So, for instance, find the number of mushroom pizzas sold each month. Round your answer to the nearest integer. Okay. So remember that in a frequency distribution, I'll go ahead and pull this frequency distribution. in a frequency distribution, we start with a frequency and then convert it into a percent. Given a percent and the total, the n, that number right there, we can actually work backward from percent to a frequency. So I'm going to go ahead and scroll down here and then do this question for us. So again, it asks, find the number of mushroom pizzas sold each month. Round your answer to the nearest integer. Okay, so mushroom is 45% of our month, and it's 45% of 1,400. So if we want to solve this, we need to say, all right, well, I have a proportion okay, so in a proportion we have two fractions. We have a percentage fraction, and then we have our actual straight numbers fraction. It'll make sense in a minute here. So the percent that we have of the entire thing for mushrooms is 45%. And a percent, as you remember, is always out of 100. Okay, so this fraction right here is 45% out of 100%. We want to make a fraction over here that says basically the same thing, but with different numbers. So remember that a percent is part of 100. It is part of the whole thing. This part is 45, the whole thing is 100. We want to make this say the same thing, a part out of a whole. So what we want to know is, find the number of mushroom pizzas sold each month. Well, that would be a part of all the pizzas that we sell. And all the pizzas that we sell is about 1,400. So the whole for this one is 1,400. Oh, I didn't think about that. And the part is, we don't know. That's what we're trying to find. So what we can do is we can solve this proportion. There's several different ways that you can tackle it. The way that I tackle it is this. We take the two numbers that are across from each other and we multiply them. So the two numbers we have across from each other are 45 and 1,400. Okay. So now we're going to need to multiply those. So 45 times 1,400 equals 63,000. Okay, and then what we do with this number is we divide it by the number that's left over. So we multiplied these two numbers together, then we have this left over here. So we're going to take 63,000 and divide it by 100. And that is going to give us 630. Oops. And so there's our answer. There's our X. This is how many mushroom pizzas we sell in a given month. So 630 of them, which that's a lot of pizza. But again, the idea here is that given a percent, we can work backwards through our frequency distribution and get back to our frequency from the percent. We can go either way here. Okay. So, again, I think I mentioned this in the previous email, short lecture. Wednesday, we probably are not going to have a lecture on Wednesday. Whoops. Go away. So Miss Elba is going to be, not Elba, yeah, Elba Lamar, Miss Lamar, sorry. She's going to be giving a test pretty soon. She has a review out there for y'all, and it is due, I believe, Wednesday. So what I'm going to be doing is I'm just going to give y'all some time to work on that review during the normal time that you'd be doing my class. Okay, so for those of y'all in Zoom, that doesn't mean a whole lot. For those of y'all who are watching this from my actual in-face classes, again, we're come to class on Wednesday, but be prepared to just be studying, and I will be helping everybody as much as I can to review for this test that we have coming up. Okay, so I think that'll do it for today. I hope everyone has a great day, and I'll see y'all again on Wednesday.